All right, so we're going to do some trig today. So remember, I'm going to write a bunch of stuff down here. Remember SOHCAHTOA. So SOHCAHTOA is how we remember the trigonometric functions of sine, cosine, and tangent. Oops, SOHCAHTOA. I got to write it out first. SOHCAHTOA. And that means that we have sine is equal to the opposite over the hypotenuse. Cosine is equal to the adjacent over the hypotenuse. And tangent, and usually we would put theta in there, so maybe I should put theta in there. So sine of theta and I'll sketch this out. You might need a little review before we get started. So sine of theta is the opposite over the hypotenuse. Cosine of theta is the adjacent over the hypotenuse. And then tangent of theta is the opposite over the adjacent. Okay, so what does that mean? Well, in right angle triangles, I don't think I'll be able to draw. Yeah, let me just get an image real quick off the internet. It'll make things a lot easier. So what does this mean? Well, this means this. Okay, that SOHCAHTOA. So sine is the opposite over the hypotenuse. And we could say angle A. Actually, let me find one with theta. Hold on, let me back up. Let me find one with theta. So we got this one instead. So let me get rid of this one. I like this one. This will work. So copy the image. So basically, we're going to have a right triangle. And a right triangle, just in case you forgot, right triangle has a 90-degree angle. And theta is the angle over here. And the side across from that is the opposite because it's opposite of where the angle is. The side across from the 90-degree angle is what we call the hypotenuse, and the one that's left over is called the adjacent. So sine of theta is which is sine of theta is equal to the opposite over the hypotenuse, and cosine of theta is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. So that's where all that stuff comes from. And they give us a problem. They say that tangent of theta is equal to 5 over 3. So let's start there. Tangent of theta is equal to negative 5 over 3. Okay, so what does that mean? Well, that means if I draw my little right triangle, right, it's not the greatest right triangle, but this is my angle theta, and then way over here, this is the opposite. And so this is the opposite over the adjacent. So it doesn't matter if I make it positive or negative, but this is 5, and then my adjacent is 3, okay? And so the question that they're wondering about is, if theta is an angle in quadrant 2, what is the value of sine of theta? All right, so let's figure that out. So we got to do some algebra review too. So this is my xy plane, right? Got a little away from me there. So then this is the x-axis. This is the y-axis. And this is quadrant 1. So it's divided into 4 quadrants. This is quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4. And so they're saying theta is right here in quadrant 2. So that means that my right triangle, let me change the color on that so you see it a little better. My right triangle lives right here. So this is my right angle, and theta lives right here. So now we got to think in terms of x and y. I'm going in the negative x direction, so then my adjacent is -3. And then my opposite is going in the positive y direction, so my opposite is equal to 5. So what does that tell me about sine? Well, sine of theta is really the opposite over the hypotenuse. Well, the opposite we know is a +5. And the hypotenuse will have to be positive too, but I don't know what this is yet. So how do I find that? I use the Pythagorean theorem. So the Pythagorean theorem for this thing is that, well, basically we're used to a squared plus b squared equals c squared, where c is the hypotenuse. C is the hypotenuse of the right triangle. Well, except now we're going to say the opposite squared plus the adjacent squared is equal to the hypotenuse squared. Well, I now know that my opposite is 5, and that's squared. And then I know that my adjacent is -3, but guess what? That's squared. And that should be equal to my hypotenuse squared. So I've got 25 plus -3 squared, which is 9, is equal to h squared. Okay? So, man, this is a lot of work, but we're almost done. So what does that mean? That means that that's 34 is equal to h squared. So now I'm going to take the square root of both sides, and I get that my hypotenuse is equal to, we just leave this as a square root of 34. So then sine, if I scroll down, sine is 5 over the square root of 34. So sine of theta is equal to 5 over the square root of 34, but we never want to leave a square root in the denominator of a fraction. So what we do is rationalize the denominator by squaring the square root. Whatever I do on one side, whatever I do on the bottom of the fraction, I got to do to the top. So then the final answer is 5 square root of 34 all over 34, because when you square a square root, you're left with the base. So that's just 34. So my final answer is positive 5 root 34 all over 34.